Hello, everybody. So, I guess you all hear me. I have no idea if you do, but hopefully you do. Nice. So, welcome. This is a little bit of an experimental workshop from our point of view, so allow a little flexibility. We'll talk, of course, about SIP troubleshooting. We are, as Daniel introduced, authors of some SIP troubleshooting tools ourselves, so this will be sort of the center of the workshop anyhow, because, of course, we'll talk about what we know best. But nevertheless, we'll mention pretty much everything that's in the spectrum or in the normal spectrum. So, yeah, let's just get going. So, Alexander?
Okay, it's me. I'm developer and founder of Homer project. It's a zip capture project, and I also did a lot of contribution in any open source project, like in the Kamailio, Free Switch, and so on. And I'm voice expert at QC AG. It's the biggest company in Düsseldorf.
I'm Lorenzo Mangani. I work with Alexander on the Homer project. I joined him a little after he created it, and we've been working now 4 or 5 years on it together. I also work as a voice engineer for a large cable operator, out of scope for today. But yeah, basically, we do this all day long as a job and as a hobby. So this is our daily stuff.
More hobby, yeah.
Before we go on, we would like to do a quick raise of hands, just to get an idea of the, let's say, preparation of the audience, just so we can calibrate the workshop going. So the first group, let's say, with voice pals, so people that don't really do super technical things, but nevertheless work with the network. Raise of hands.
No, you're not.
Invalid, invalid. Great, so voice ops is where we expect to have the most people.
Okay.
Good. 60%. Developers. Fair enough. Good. So we should be
okay. Now
okay. Yeah. A little introduction. So today we will not, of course, get into depth about the SIP protocol. We expect that everybody in this room is more than fond of it and knows already everything that there is to know. So what we'll do today is try to cover the tools which are involved on a daily basis on many levels with troubleshooting SIP protocol mostly. Approaches as of using those tools in reality. References, links, community projects, ideas, and everything else will be included in the slides, which will be also available later on. So if we're skipping on some of them, don't worry, we'll get there. We will not get into explaining how to do the actual troubleshooting. We'll talk about techniques to get to the packets, capturing packets to do our job. In the presentation, we'll mostly talk about open source items. Here and there, we'll mention some commercial tools, mostly for comparison and just to describe the ecosystem of solutions that are available. But it will be just references. So, the battlefield, some assumptions. So still, everything that we'll say today is just based on our experience, so people might have different ideas. Feel free to interrupt us or extend. But in this slide, we list what we believe are the main areas of investigations where troubleshooting VoIP. So interoperability issues are occupying the first position. So in this category, we have anything that falls into partial understanding of implementations, RFCs, incompatibilities, misconfiguration of platforms. So sometimes the platform is perfect, but you messed it up configuring, or the other side did. Negotiation issues are also a big one, which is, of course, largely included in troubleshooting sessions. So anything from codec negotiation, P-time, different DTMF transport methods, bad network paths, net issues, and so on and so forth. And of course, anything that falls within the SDP hell, it could be anything in there. I guess we all had our good experience with it. System performance. So sometimes it's not about the protocol, it's just about the systems. You're doing everything right, but you're doing just too much of it. Or you're overloading your gateways, transcoders, whatever else. Or on the other hand, somebody else is. So maybe you're under attack and everything is perfect from a configuration standpoint, but somebody is messing with it. Of course, network performance. This is a little bit external to the platforms that we usually configure and troubleshoot, but nevertheless, it's an element which helps us exclude the issue belonging to our network, for instance. And of course, OSI 8, the user, the number one
common mistake.
Yeah, generator of issues, if not pointers to the issues. We will also make a few assumptions as of the typical systems that we'll deal with. This is by no means a complete list. It's just a few examples of what we'll deal with today, what we'll mention. So user agents, SBCs, back-to-back user agents, full soft switch platforms are the ones that, of course, provide the most information. You'll find the protocols there, SIP, RTP, RTCP. Then you also find CDRs, metric, application logs, and whatnot. Everything is useful. We'll see how it can come together. And we have, of course, proxy registers, routers, where we mostly will find signaling traces and some logs. Then, of course, we have raw network devices, so mirror ports, routers, switches, get all you can. And again, we listed the user as well, because the user is, of course, in many times the originating point of an investigation. Somebody raises an issue, they give you a time pointer. So we included in the list of peripherals that provide output, which can be useful. We'll do a little bit of retrospective. So we'll start from the standard tools that most likely everybody used and still uses on a daily basis. We'll go very quick on this. It's just to create, let's say, a first level, which will be over. So just a little introduction. What we really need to do on a daily basis to do our job is capture packets. We got to get to those packets. We got to see what's in them. And we got to do our investigation. So regardless of the experience, regardless of the specific job you're doing, you'll find days where it's easy to do it and days where it's impossible, where you have to access somebody else's system, and more than not, they will only have a TCP dump, and all of a sudden you're stuck with that, and you have to merge it or bring that traffic into your normal troubleshooting patterns. So we'll see a little bit of those in this first part. We'll mention the tools that you see here: TCP dump, Wireshark, T-Shark, ngrep, our own SIP grep, SNgrep, and all the way up to capt agent,
It's also
which
ours,
is the also ours, and it's the gateway to the second part of this workshop. Of course, many of those tools will do the same things, so we'll mention them overlapping each other just for convenience. So the first, of course, it will be TCP dump. I don't think we have to stick long on these slides, but this is most likely a few examples of stuff that you did a million times.
Yeah, it's standard feature on, standard application on all system.
This is why we mention it, because we'll get as complicated as centralized capture systems, but sometimes you will just not be able to use them at all, just simply because the remote system will not allow it, or this is just what you're stuck with. So a few examples here. No need to talk much about TCP dump. Same category, we have T-Shark, which is distributed with the Wireshark application. It's basically the terminal version of Wireshark. Very useful tool. Of course, it can capture. It provides you all the filters which are available in Wireshark, so it's sort of native to many of us. You can capture other protocols, of course, and very interesting, you can also do RTP heuristic analysis. So if you have RTP streams and you quickly need to know post-mortem what happened to them, T-Shark is one of those tools that allows you to pull out some information very quickly. And we also actually use it to calibrate some of our applications as a comparison tool or whatnot. But many times it's there. All of those tools are, of course, also useful to perform remote capture. So I guess we've all been there as well. The remote system from one of your customers, users, whatever else, only has limited tools. You want to fetch that traffic onto your troubleshooting platform, for instance, or your local system for investigations. And here we list a few ways of common tools to do this kind of job. They're, of course, much more related to the Linux system and piping than the application themselves. But nevertheless, we have an example here with TCP dump, Wireshark, and one with our own SIP grep. SIP grep is interesting because, of course, it cannot only help you troubleshoot the packages, but it can also do more with them. We'll see it in a second in a dedicated slide. In this case, we're forwarding it to a collector. So you're getting packets from a remote system with a pipe. you're looking at them on screen and filtering with HepPipe, and at the same time, you're shipping them off to a remote platform where you'll keep them, store them, or investigate them later on. Another big point is, of course, encrypted SIP, which is becoming, luckily, more and more popular. The same is not for troubleshooting tools, so I guess still nowadays it's somewhat involves a lot of manual work to get to encrypted sessions. This is actually information straight off the Kamailio wiki, and we have a couple examples how we can do, again, post-mortem, not real-time, analysis of SSL streams with limitations. Of course, as probably most of you know, with recent versions of TLS, you cannot.
Yeah, you had handshake, you could not anymore to decrypt it also with private key. Probably you can ask NSA, they can decrypt it for you, but.
Luckily, on many of the systems that we all work with, Kamailio is one, we are able to do the investigation and the mirroring of the encryption path. So you can still have full encryption with your customers and do your full investigations on the inside without going insane. Not always the case, but we thought we'd mention it. Second category here, we have all still old school and command line tools, which we consider classics. This is a little bit of a higher step. Something that you've seen probably in 100 million tutorials is PCAP SIP dump, which is really a tool which is able to split two-disk SIP and RTP sessions.
It's very old, but still usable.
Yeah, I mean, it's in many cases, you know, when the problem is simple, this tool still can cut it. So if you're investigating, sorry about this, I have allergies. When you're investigating limited scenarios or simple conditions, this can still be useful. Of course, if you're looking at a whole lot of traffic, using this kind of approach gives you another problem, which is figuring out what the hell you captured and what's what afterwards. You know, when you have thousands of files, you created a problem probably bigger than the one you were trying to solve. Mentioned here for completion, SNGrep, which probably a lot of you also have used across time, is a beautiful terminal tool, a little bit similar to some of the things we do. So it's basically can run for a period of time in real time, or you can read from a PCAP, and it gives you a few facilities like a call list window. It creates a simple terminal call flow, so you can have an idea very quickly of which messages were exchanged between which hosts, and so on.
It's nice tools in Carses. It's used in Carses library, and it's very interesting and very useful to find the problem.
Again, one of those tools that you'll use when you cannot do anything else.
No, the server, Victor, is used it, yeah? Yeah, I saw.
And here we have, we're getting to SIPRep. It's actually SIPRep 2 because it's the newest version of it. Maybe Alexander can share a few details on it.
Like Daniel already mentioned, the first version of ZipGrep, it was released in 2005, yeah, probably. Yeah. It was a small wrapper script behind ngrep. So it was colorized. You can make also parsing, and it was very, very useful. And immediately it was distributed in there and in free switch by default. But after some time, we decided what we need to rewrite this Perl script and write real C application, which will be powerful and has the same functionality like first ZipGrep had. And here you are. We have ZipGrep number 2. So like I mentioned before, it has a lot of features and same functionality like old ZipGrep. You can use regular expression, make any matches and unmatches in your capture scenario. And also you can, it was a request from Daniel, also you can start ZipGrep in collect all messages in a batch job and just split it on based on file size or on timestamp and so on and so on. Also nice feature, what we mentioned already, is you can use ZipGrep and duplicate all traffic what you captured in real time to Homer system in HEP protocol. So you don't, for example, you started you have a trouble, you started capturing, and immediately all messages will be stored in Homer, and you can also save like PCAP or HTML export and so on and make analysis. Nice, but not the last feature in ZipGrep. Everybody knows friendly scanner, or it's next one, yeah. friendly scanner. It's annoying, it's disturbing, and so on and so on. And in this case, we have implemented a nice feature which sent message of def to source IP address who sent off friendly scanner or zip CLI. It can run in background. It can use also in custom user agent name, and you can just start it in background and forget about your attacks. Okay, here it's like I mentioned already. It's split into file size. You can save directly in zipgrep, in pcap file for later analysis, and just to make batch and remove old files if it's not needed anymore. And of course, it's a very nice feature what you has a colorized output of zip message. So it's make color for method, for reply, for call ID, of course, and for important stuff is branch and to and from tag. So you see immediately on your terminal to which session or to which dialog this message can relate it.
Absolutely. So basically what we try to do here is just put together all the features of all our favorite tools into our own. And we think we did a pretty good job. It will be up to you to confirm. We'll see again CPREP down the road because it has a few more features that we do actually use. And this sort of completes the generic part of the, let's say, command line or old school approaches to packet capture and troubleshooting. Now we step into what we think is more of our realm, so capture servers and long-term storage solutions. Let's start by saying, by defining what those solutions actually do. So in general, of course, they're designed for operators and service providers of a decent size. So normally, if you have 10 customers, it's overkill to have something like this in place. Not necessarily, but in our experience, this is something that kind of comes with the size of the business. The more it becomes critical, the more you need to be able to do the troubleshooting at any given time without any preparation. Anybody needs to be able to just kick in, find a problem, investigate, and hopefully bring a solution. Yep. So this is where we actually concentrate. The key benefits, of course, of the many products which do the same job are similar overall. There are commercial ones, there are free ones. Actually, well, there's a fully free one that we do, and then there's many commercial and semi-commercial solutions out there, which we'll list after. The benefits are very similar. So it's an agnostic capture platform generally, so it's not related to the systems that are handling the traffic, but it's off the platforms. It's an abstract view on the traffic. It's permanent, so you don't have to do any work, you don't have to do any preparation. Most likely all of the traffic that the network generates is stored for a period of time and is available for troubleshooting. It's instantaneous, so let's say the engineer in charge of the case doesn't have to figure out how to do his job. He just needs to know the details of the problem, time, stamp, user, request URI, whatever else, a call ID, anything else. Yes, this is of course part of the setup. This is kind of at the tail of it, so the preparation of course involves preparing the mirroring of traffic. Sometimes it can be done within the platform, so if you use Kamailio, FreeSwitch, Asterisk,
it's already integrated.
OpenSIP, you have an integrated capture agent already in all of those platforms, which you can just configure to mirror those packets.
And also in Asterisk is also.
Yeah. If you don't, you'll do it of course of mirror parts, of switches, whatever you can use.
No, normally not. It's if it's only zip messages, it's nothing. Yeah. We are not talking about LTP, full LTP analysis. So zip messages is, let's say, it's around 2-3% of your completely voice traffic.
Of course, you'll have network overhead for duplicating all of those packets.
In this case, we implemented also in HAP, we implemented compression. So if you care about traffic, it will be too much, 10 megabits per second. So you can use compression.
This is in our own capture agent, just to be specific.
Yeah, it's in roll socket mode.
Yeah. Otherwise, all of the, let's say, leading open source solutions have a HEP, which is the encapsulation protocol we designed, capture agent already within. And it's just a matter of configuring a couple of lines to have it ready working. where were we? Oh, okay, long-term storage, of course, when people can afford it or when they need it. The data retention is, of course, a requirement for anybody that does serious business with voice. User benefits are also on the same field, so it's those platforms are actually accelerating access to the information. They reduce the complexity of investigation. They reduce unsecured access to the system, so all of a sudden you don't have to give all those guys access on the source switches to do their TCP dumps, but they'll find it already somewhere else. No passwords, no security risks. And then, of course, we empower teamwork, because all of those platforms really allow users to more easily share their cases, ask their colleague for advice, send it to somebody else. They just make our job much easier. Here's a brief list of some of the solutions that we felt like mentioning. You'll see that most of them are commercial. So most likely you know or have used some more of this. What we'll do today, of course, is focus on Homer for two reasons. One, we write it, so we know exactly what it does and we can describe it. Two, it's free, so you guys can all go and get it tomorrow.
It's free, and it's based on Kamailio also. Yeah.
That was an additional point, but yes, it's really powered by a Kamailio module. We'll see how in detail later on in the slides, or even tomorrow that we have a dedicated presentation where we present the new version of Homer. Today you will have a little bit of a sneak preview to it, but tomorrow it will be the first full-blown presentations, and there's a lot to be seen, a lot to be presented. So I hope you will all see it. So here what we have, Homer, SIP Capture, of course, it's our application. VoIP Monitor is semi-commercial, so it has some open parts, but the user interface is not. Empirix is a big classic giant. Anybody that has...
Too expensive?
Yeah, that's been working in a big network for some time, probably have used it. pCapture is our commercial application for it. We will not mention it much today because it's commercial. Oracle Palladion, which used to be IPTago, is something that we also think many of you might be familiar or know about. SolarWinds, be aware, there's a lot of them. We just mentioned a few here. The point is that unless somebody else can contradict us, ours is the only one that's completely free. So let's take a look at it. It's a good example, and as we said, the features are similar. So many of the things that we'll say today apply to more than our own platform. So what is Homer? For those that don't know, Homer is really a tool set, but let's say it's an appliance, which allows engineers to just focus on their job and not on the technical aspects of capturing. So as we said, it really comes together as let's say, a centralized capture location and a swarm of capture agents. Those capture agents might be within the platforms that you use, or they might be external. They might be feeding traffic from switches. No matter what, they will all be duplicating SIP methods and send them to a centralized platform, where they are collected, correlated, parsed, and so on. The solution, it does what we just mentioned, so it gives you instant access to all of your past and present signaling and statistics, if you generate any. You can access immediately the full SIP and SDP payload for investigation without sweating much. You have automatic correlation of sessions, so in a back-to-back user agent environment, the system is able to pull together all the legs into your platform, through your elements, and out to the peers with many ways that you can, of course, configure and tailor to your own likes. It provides visual representation of everything that we're talking about. So here we have it's a small screenshot, we'll see it better later on. But yeah, we have visual call flows, we have full packet display just in a few clicks, and it's all in a nice user interface. Everything is pre-parsed, so yeah, exactly. The methods are already pre-identified, and when you see them in the system, they already have produced statistics within the system. So you can investigate either looking at a specific session or looking at your statistics and seeing, for instance, hey, we have an attack, going to investigate that specific time range, IP addresses, whatever else. It doesn't need any clients on your machine, so it's a fully web application. It's very easy to integrate with third-party applications and scripts at this stage. It wasn't until some time ago, but now it is via our API. So you can, whatever you have in this system, you can, of course, use the interface, or you can query it from your own scripts or a third-party
but
platform.
Mention it's tomorrow.
Yeah, this will be presented tomorrow, and then it's easy to install. So once you set it up, of course, it's not always a 5 seconds job, But in most cases, once you have set it up, you can forget about it and just keep using it for the years to come. Homer 5 is the version that we'll present tomorrow. So today, we'll just reference it, consider it a little bit of a sneak preview, and of course, the description of the platform per se. The web application is now an Angular-based UI. So it's very flexible, very, let's say, logical, and it's easy to extend, unlike the previous one, which was a little bit messy and
PHP
custom.
and jQuery.
But again, this is a little bit of a sneak preview into tomorrow. What it does, or the main features are still very similar. So it's a production-ready system. You can just throw real traffic at it. It's not a lab tool unless you want it to be. It can have an unlimited number of capture agents. Of course, this is related to the hardware capacity as well, but in pure theory, there is no limit to the amounts of
But we can say, like Apple says, it's now new Homer, it's more powerful and the same price. Yeah.
Yes, same price, free. So you can have as many capture agents as you want, and this is very important because it's easy to set up a platform, but then next week, next month, next year, you're going to expand, and if you have to continuously invest money on keeping your capture infrastructure up, it sucks. So in this case, you don't. You just add a new system, you couple a capture agent with it, and you're off to go. Multiple database options. So by default, we use MySQL or MariaDB, where it became the default choice. Postgres. We also have added support for Elasticsearch and InfluxDB in the latest version. We'll see how and why. Not necessarily for SIP methods, but for statistics. We already mentioned its Angular-based interface. This time it's very easy to extend. It's very easy to customize, create new widgets, new analytics functionality. So if your company does something which doesn't fall into the average statistics, now it's very easy to build your own widgets and functionality out of Homer 5.
Are you guys looking at any of the NoSQL kind of databases, especially if you're going to be doing some data?
There you go. It's yeah, we do. We implemented support in version 5 for NoSQL. Right now, you can go at. You're welcome. We did it for ourselves. It's just a coincidence that we give it out.
Of course, there is some limitation because its index still a big problem.
Yeah. Well, what we did is really allow the platform to be able to do it. So now it's a little bit in your hands. You can experiment as much as you want. If it works, great. Hopefully, you share it back with the community. If it doesn't, you'll move on to the next option. We just removed all the limitations and let's say, the hard-coded approach that we had in the previous version. So it was MySQL or that's it. Right now, you can really do it in different ways with different results. Again, we have native call flow display in Canvas, so everything is very beautiful and cross-platform with a modern browser.
You have to not to install HD library anymore or ImageMagick and PHP.
Exactly. There is no more server-side processing of anything. Everything is done on the client simply with the information coming from the API. Yeah, 100% API-based, of course. This comes with it. Multi-user support and external authentication. And a beautiful community. So we have a lot of good guys which are working hard, if not to develop the system, to give advice to those using it. And that makes a difference. Let's take a look at how it became. So if you already knew Homer, this is how it looks today. We changed completely. It became, let's say, it's almost accidental now that you have a SIP search application within. The environment is really more generic than it should be. So it's a, let's say it's a time range based application where you can do a lot of sub functionality. In this case, we'll present, of course, the SIP search because this is what we're interested in, but not necessarily the only thing it does. It's still similar to the previous Homer, so you can now build your own search forms. You can have whatever you want there. You're not anymore limited.
This is widgets, yeah? Now it's for widgets, which you can create it in new widgets and make definition which fields it should be in these widgets.
Presented tomorrow,
yeah,
1:30 after lunch. You will see exactly how you put those together. But just know that this is all dynamic. So new Homer doesn't come with anything pre-built. You make your own forms, you make your own charts, you make your own results.
No spoilers.
No spoilers, exactly, at all. Typical search results look somewhat like this today. So you have it's a table chart of results. The call ID is the primary driver. You can see there key colored by call ID, just to quickly tell apart what you're looking at,
In
different
which dialog,
sessions. Yeah, which dialog. We implemented now native filtering on the results. So if you do a two-tier, let's say, job task, first you look for time range, then you look for the specific call or a specific user. This is very key to it. If you click on the call ID, the system automatically pulls the session details, all the messages that belong to that session, the hosts involved. If it's a multi-leg or back-to-back session, it will be correlated and you will see it. But this is mostly how it looks. So you will see the two hosts, IP port related to the session, the methods going back and forth, the timestamp for each, time difference, and so on. If you click any of those, you get, of course, the full message. You can see it raw, as you see here, and we have another tab with details where you can see pre-parsed headers. Just if that makes it easier, some people don't like to do the full work. And we also have, of course, this is, I think it was well introduced already in previous versions, but we have RTCP and QoS reports directly into Homer. So if
before it was FTCP, just FTCP.
Yes.
But now we have a little bit more support.
Yeah, we extended it quite a lot. So this is by, let's say, the default, what it does. We can parse, process, and present RTCP XR reports directly into the session. So if one of those user agents involved with this call was sending RTCP XR, no matter where they were on the back-to-back session, they will show up all here, and you will be able to see with a granularity what happened to those calls. We also support logs, so now you can send arbitrary logs. If you have, you want to forward your Kamailio logs with the call ID as a correlation and see them in the application, now you can.
Or some additional statistic, for example.
It could be anything.
Yeah.
So if any of your elements produces logs that you require for the investigation, now you can attach them to the session here. And yeah, I mean, we will leave it.
Yeah, sure.
It paints a nice picture for troubleshooting. This is how the charts looks now. So you can produce whatever you wish. So you can just take the data straight off our API and choose how to represent it. You want it in bars, charts, lines, area. You want to mix it. You want a percentage.
So you decide
all in your
now
hands.
by self.
We provide some presets. And on the wiki, we'll publish some, let's say, default recipes that people can implement. But we expect that now that it's possible, people will do whatever they want. Another example here is the extension, what we were talking about before. So right now, you can make statistics off the Homer data, which is on the right side.
It's MySQL statistic on Homer.
Exactly. So here we can see the packet rate, for instance, and the method distribution on the platform. And as you can see, we also have other queries that have nothing to do with voice, but will have a lot to do with investigation. So at the same time, we're looking at top layer 7 protocols on the network that we were investigating, the top IP sources, a histogram for all the data we are getting Elasticsearch, and the server load of the machine that's running Homer.
In the lab.
So as you can see, now it's a lot more than just looking at SIP statistics. In Homer, you can literally also monitor your SIP infrastructure. Whatever it be. So there's many ways in the workshop, in the presentation, we'll see more details. But just know that you're not limited anymore to what Homer has stored within itself. You can access anything else that's relevant to you for the investigation. How it works with Kamailio. And here,
Okay, just yes. 2 words. So exactly what's the question, how it works with Kamailio. In Kamailio, we have 2 modules. It's a zip trace module, which duplicate all zip messages in HEP. And we have zip capture module, which we wrote this module by itself, which receive HEP messages, make parsing, and insert these messages to database. It also can, of course, be in roll socket mode, but we prefer now to use HEP, because in roll socket mode, you have some problems with defragmentation, reassembling, and so on, so on, so on. So what I didn't mention in zipgrep has already TCP and UDP defragmentation and reassembling, and new kept agent also. But we prefer to do its native in Kamailio via zip trace application. So it's very easy. You can also send traffic from FreeSwitch, from SBC. It has also support IP/NP encapsulation. So if you have ECMI packets, you can just say all messages should be duplicated in IP/NP encapsulation to destination Homer. And it will be stored in database, can be make analysis, statistic, and like Renzo explained already, you can do full text and zip messages search.
And of course, the same is available, not to be racist, in both OpenZips and Kamailio, pretty much the same way and with similar details. Here we have a few...
yeah, okay, I can mention exactly what is big changes in Homer 5. So a new module, zip capture, just some rollback. Yeah. It's in 3.5, we use one big table, it's called zip capture, which was partitioning by time range. Some of our users complain that it's very, very hard to change fields. For example, if user, by default, a message field has limitation 1,500 characters. If you have a bigger zip message, of course, you should to change. But it's always come later. And to change data where is already stored more than 20 gigabytes, it's impossible. So you should drop and recreate table again. We decide to do another way. We create for each day a new table, which also partitioned by it's splitted by time range, by timestamp of this day. And also it's partitioned by time range in this day. What it means? It means what if you would like to change table, some fields should be changed, you can change for next day and it will be automatically applied. So you don't need to change and drop tables anymore. And another big changes what we implemented is now all traffic splitted by method or by, let's say, by transactions. So all messages which are related to call, it will be stored in table zip capture call, you see here. It should be, yeah, zip capture call. Info, it can be also stored in zip capture call if it's in your network, a lot of info messages with calling complete and so on and so on. Registration can be saved in the registration table. And at the end, we add just in extension year, month, and day. And we say it's this message should be stored in this table. What we have at the end, we have splitted traffic. We have less EO weight during search. We have possibility to make long archiving if it's need to just move table to tapes and so on. And of course, it's speed up and quick search. And from left side, just typical alarms and statistic example how you can make what everybody knows already. It's already implemented this 3.5. Just here it's extended, and I will mention this tomorrow. How you can use triggers now based on tables and records in MySQL.
So the bottom line is a lot more flexibility. You can do more stuff your way. You're not anymore locked to the way we designed it or the way it works for 95% people. You can take your 5%. The same thing applies to also RTCP XR. Kept Agent, new version, which will also be presented tomorrow, introduces a new feature, which here we just mentioned because it belongs in the topic, to handle RTCP XR. So RTCP XR can now be directly fed into Homer from the capture agent, or it can be forwarded and processed in Kamailio.
In Kamailio. So you can split, you can extract call ID from body, and use this.
We're talking RTCP XR publish messages.
Okay, if you see more firmware with Polycom or SNOM devices.
Yeah, this is described in RFC 6035 if you're interested, and it's present in many, many devices. We see a huge number of those on the networks of our users. So we decided to bring this up the roadmap, even if it's nothing new, but it's, we believe it brings a lot to the table when you mix it with the SIP troubleshooting. Yeah, here's another little recipe for...
Yeah, okay, I will explain. Also, one of our users say how I can store or use Homer for long-time archiving. Of course, put everything to MySQL is a little bit heavy and too expensive. And we decide to do another way. You can use FlatStore database. So it's FlatStore database driver, which is also included in Kamailio. You can install separate server with Kamailio and file store and save all zip traffic to file. So it will be already splitted, like this, comma separated or semicolon separated. And in batch process, you can make, archiving with zip2 or whatever you want, and save everything on tape. So in which time, if you, for example, you need to store data for 180 days, 6 months, and one of your customer complain, okay, 4 months ago I have some problem, and you should pay penalty or something like this. And you can restore for tapes, put everything from flat database to MySQL, make search and make some analysis, and but it's all.
Yeah. We mentioned before, there's now an installer for both Homer and CaptAgent on our website. Thanks, Daniel, for helping with it. Which hopefully will make our life a little bit easier. It's nowhere near perfect, so this is still a work in progress. Yeah, I mean, it will take you closer to the installation for sure if you start from scratch. On the CaptAgent side, I would say it's flawless. On the Homer side, it's changing right now to support the new version, so we'll need testers. Please go break it. Now, we mentioned how to feed data into the applications.
Okay, let's go.
Yeah. We have a bunch of methods. We already mentioned many of the leading open source voice solutions already have an app capture agent within. So if you're using Kamailio, OpenSIPs, FreeSwitch, Asterisk, SIPXX, for instance, you already have a dedicated capture agent which you just need to configure and it's ready to go. If you don't use any of those, then you can use our own CaptAgent project. You can see there's links and examples to configuring all of those on our wiki. We also do provide coding samples for Java, C, C++, Erlang, Go, and more to come as of implementing the HAP protocol in your own application. So if you wish to bring HAP power to your own realm, you can. You can find a few examples. It's easier than it sounds. CaptAgent 4 is the current version. Tomorrow we'll present and release version 6. From many point of views, they are doing the same job, so we'll just mention it. It's a dedicated capture agent for unsupported systems, so you can either install it on the system that is running your voice infrastructure, if it's compatible and you have resources, or on a dedicated system which is feeding from it, either via whatever, switch mirroring or whatnot. With it, out of the box, you have a universal proto module, which right now takes care of SIP and XMPP. Captures, encapsulate them off to Homer. RTCP, which we just mentioned in version 6, is largely extended for RTCP XR as well. CLI, HAP, of course, encapsulation module, and it supports SSL and compression. So
for transport, if you would like to send your HAP traffic on
let's say you ship it from a customer to your centralized system over the public internet.
So you can use SSL and compression. So
this saves you up to around 30% bandwidth and encrypts everything. So it's okay. We also have a remote API module which allows to configure it. Again, this will be better presented in the tomorrow's topic. SIP-rep, as we mentioned before, can also be used as a disposable HAP3 capture agent. So you're not limited to troubleshooting on the screen. You can choose to fork all of the traffic that you're filtering, seeing to Homer or another platform and investigate it later or leave it there for others to double check your work, whatnot. The option is -H, and it just needs the protocol, IP, and port of your Homer instance. This is extremely useful on, let's say, virtualized infrastructure and so on, somewhere you can just park a quick agent. We have also this year introduced HAP support in NTOPS products. So nprobe, which is a very, very powerful probe, already came with some basic voice functionality, which we have, together with our team, extended. So now nprobe, if you use it for anything else, supports also HAP encapsulation protocol. It can generate full mirroring of traffic, statistics on it, and even RTP statistics. We'll see it down the road. We'll see it right now. So in Homer, we all know you can do signaling, but you can also now have media QoS details. So What we'll bring into the system, of course, we'll look at RTP and RTCP primarily, but we'll also feed RTCP-XR and XP RTP stats, which are generated by user agents directly. All of those are supported out of the box now in Homer. So if your devices are producing any reports, they will just automatically show up as long as you capture them, of course. If they need to be sent to a dedicated collector, the collector can be now capture agent. So your capt agent instance can be the receiver of those reports. Here's an example how it works. There's a little diagram. So your IP phone is already making traffic to your soft switch. Let's imagine your soft switch is already HEP mirrored, and you just need to additionally cover RTCP-XR reports. You just configure a socket for it in capt agent 6, and you just start shipping traffic to it. Capt agent 6 takes care of the rest, so it can correlate them to the session they belong to.
It's exactly kept call ID from body. From RTCP-XR body and use this like correlation ID in the HEP protocol. So nothing more.
So here we mentioned a few devices, NOM, Cisco, Polycom, but there's more which support RTCP-XR, and many more support XMP RTP stats. BearZip is one. Is Alfred here? He'll be tomorrow if not. But BearZip is a fantastic console zip client, which we have extended to support statistics. So now it's beautifully...
First, this was extension exactly XRTP statistic, and now we extended to use XRTP. So if you would like to see, it's don't miss dangerous demo.
Yep. So here we have another little tool which we wanted to just mention for lower intensity cases. There's a nice Java application which is the Reaper. What it does is basically sniffs all of your traffic, and it generates synthetic RTCP-XR reports based on whatever it can find. So if you have real RTCP reports, or if not, you can do it off straight RTP analysis. What it does, it produces basic reports. Once again, those can be sent to Homer, or they can be used separately.
Unfortunately, it doesn't send MOS, but you can calculate it by yourself.
Yeah, well, we'll do something about that too. Tomorrow as well. This is something from which we are presented here as last year's version. Tomorrow you will see the brand new one.
But it's not here.
Asterisk has been patched. So now we have a REST HEP RTCP module, which is specialized for mirroring all RTCP packets from Asterisk to a collector, in this case in real time. So if you have a call ongoing on your Asterisk server, and this is set up, you will see in Homer
first this was implemented in version 12. It was back ported to version 11, and now it's version 13. Yeah.
Yep.
So it should be also implemented.
Keeps getting better and better. Of course, you also have a HEP module in Asterisk, so you can do also the normal
zip mirroring.
Here we go. This is the I previously mentioned XRTP stat and PRTP stats. They are generated by user clients at the end of the call, so either in the buy or 200OK they are included. This is natively supported by Homer. So the buy and 200OK hopefully already make it to your capture platform or capture agent. If they contain this, they will be drawn and measured and displayed within the session. Here's a little foolish example of how you can also mimic those statistics from
RTP engine is now it's called.
Yeah,
sorry.
Well,
sorry guys.
This is still for RTP proxy, but the same could be done also in RTP engine. So basically, you can take any statistic that the relay feeds back to Kamailio and turn them into one of those reports, which can be then parsed externally, if you're interested into it. If you want to do real full-blown RTP statistics, you can use mprobe from NTOP, which is unfortunately commercial, but it does the job very well. What it does, it just detects automatically RTP streams on your network with an NDPI library, so it doesn't need any instruction to work. And at your own pace, so you can decide every X seconds to generate statistics for a certain leg and just ship them off.
Yeah, it's very important, but it's also support 10 gigabit.
Exactly, this is a wire speed up to 10 gig without any packet loss in our measurements. So it's very good for larger operators that need to have a visibility on their the quality of their streams without those user agent reports. The beauty of it is that it generates pseudo-MOS and R factor per report. So let's say that you have a report every 30 seconds. In each report, you will have the MOS for that segment. So this allows you, for instance, in very long sessions, to identify even very small issues which otherwise would be lost within the statistical analysis.
Also here, it's nprobe can send also the report in JSON format. You can also use Elasticsearch.
And here's the next one. So you don't really have to use Homer to do any of this because all of our tools also support JSON, of course.
Yeah,
if you want to
Homer
go,
is so ugly and
well, you know, so for some people it's too easy to just use something that works beautifully out of the box. So you might want to build your own solution in Elasticsearch, for instance. And the good news is that you can. So both nprobe, RTP Analyzer, and Capt Agent 4 and 6, but 6 is better, support JSON output. So if you wish to make your own solution, you absolutely can. We even made some extensions to display SIP traffic a little bit easier in Elasticsearch.
it's also our plugin from the free, which we will also implement in the Home of 5.
Exactly. So all of, let's say, all of the beautiful things that were in Kibana 3 will also be ported to Homer in or similar way when they're useful. Last but not least, CDRs and logs. As we mentioned, you're not limited to QoS or TCP reports. You can send whatever you want now into Homer. So Kamailio logs, useful. You have details there. You have call ID, the SIPwise platform is also a beautiful example of this. So you can take all of their detailed logs, ship it off to Homer, use the call ID as correlation parameter, and everything magically works. So when you look up for a session or a group of sessions, all of the reports, logs that are related to those sessions show up as well. This, in our opinion, changes Homer dramatically, and it makes it much, much more powerful because it's not always in the signaling. I mean, if your system is breaking down, you'll only know by the logs. Last part, a couple of automated tests.
Okay.
But maybe we don't have time, so yeah, we'll just go very quick. You will get the PDF. So just so you know what you'll find in the PDF, you can also, of course, you have malicious agents which are probing your network, but you can also have your own. This is a couple of very simple examples. So PJ-SIP user agent, SIP-SAC can be used for probing service.
PJ-SUA also supports TCP-XR. So if you would like to make some automatic test and measure of your network, you can use this application on BerrySIP.
Absolutely. BerrySIP, as we mentioned, we extended with XRTP support. So now the user agent, when you enable it, is able to produce this kind of statistics in the buy and 200OK message, which tells you a lot. We use it to probe some of our services on a permanent level. Yeah. And this is pretty much how it looks. So you have two BerrySIP agents which call each other through the network and produce reciprocal RTP statistics, which then can be compared by scripts and so on, generate alarms and whatnot. Yeah, same thing in reality you can also do with SIP, but we're going a little fast, so you will find all of this in the presentation. We built for this purpose a Raspberry Pi tester which uses SIP and BerrySIP. And that's pretty much it.
Yep.
If you have any questions, otherwise, this is all.
Questions, quickly.
That was one of the most brilliant presentations I've seen in ages. And you know, Lorenzo, just by talking very, very quickly, you can get more in. One for you, yeah, for Daniel. Can you just recap again the availability of the video and in particular the slide pack? Because there's a lot of information that Lorenzo has packed in there, which will be a brilliant, absolutely superb reference for later on. So can you get the video?
Yes, maybe Matthias can say more, just to delegate the problem.
Okay, we're making a video, you can see it here, and we're transcoding it tonight, and we will upload it to your YouTube channel, if you're allowed to.
Friday.
So back to Daniel.
Yeah, okay, I don't know about the bandwidth and if we do it this week, but will be available on the YouTube channel for Kamailio. Yeah, so practically also what the presenter was saying, and the slides are both captured in the same time and will be mixed. Matthias and Pascom sponsored that, and we're very glad they came here. So it will be quite good quality, and yeah, we'll announce it on the website when will be available, if will not be available during this event. Because I'm not sure about the bandwidth, and if I use it to upload videos and you cannot check your email, probably you'll be upset. But it'll be available, yes.
If it's help.
Questions?
Anyhow, if you need it urgently, come find us. We're here.
Other question for, last question for SIP capture, guys. Yeah.
Mm-hmm.
Yeah, and you also calculate some statistics.
Yep.
But what if the clients do not send RTCP?
Then no statistics.
No hands, no cookies.
Well, no.
jitter
We
statistics, no
mentioned a few
packet
ways. So
losses.
if the agent actually sends RTCP, then it's very easy. If he doesn't, then you have to go for one of the advanced methods. So either you look at the relay, you look at your your relay, you analyze the wire RTP. There's a few ways, but if there is no RTCP, then you have to step it up and analyze RTP.
But we don't prefer this way because it's not accurate. Yeah? So it's it's.
Well, it depends what you're looking for. If you want to measure your own network, then it's different. If you want to see the actual user experience, then nothing can really substitute RTCP.
Yeah, another question still about RTCP. What's the point of calculating the round trip time somewhere in the middle? Because it should be calculated on the endpoints.
Mostly for comparison.
What?
For comparison. So if you have the round trip time measurement of the client and you have one on your network, most likely it gives you a metric that you can use to do something. Simple as that.
And only on this way you can calculate the pseudo-MOS. Yeah.
Yes, it's necessary to calculate a pseudo-MOS score for the session. So to give it a score at different points on your network, we use it. Again, it's just for comparison. So you can easily tell, the problem was egress or ingress, or it was the customer, it was the transport.
But of course, it's the preferred method is TCP XR because it's already calculated by client and it's 100% sure. So Dr. House will be happy in this case. And second method is capturing at TCP. Yeah? It's only at TCP because also it's. Yeah, okay, it's depend of course, it's depend of user agent.
Yeah, those are device parameters. So you can only, this is something to discuss with the vendor of that device, I would say. No, we didn't see anything accurate 100% ever. It's never accurate.
But
this is why you want to measure it in different spots and you want to compare, because nobody tells you 100% of the start.
But nobody perfect, but it's better than nothing. Yeah?
Okay. Thank you, Alex. Thank you.
Thank you, guys.
So